All right, guys, so yesterday you learned about factoring. So today we're going to talk about solving using those factors. So the key to understanding where this comes from is this thing right here called the zero product property. It says if A times B equals 0, then A must equal 0 or B must equal 0. We can also apply this to factors. Think about this. If x minus 3 equals, or x minus 3 times x plus 4 equals 0, then what must x equal? Okay, so we need to think of it like this. Our A is x minus 3, our B is x plus 4, and then it's equal to 0. So that means either A or B has to be equal to 0. So just like this, x minus 3 equals to 0, x plus 4 equals 0. This tells us that x is equal to positive 3 or x is equal to negative 4. These x values, okay, are called solutions, zeros, roots, or x-intercepts. So it's important to know all of these terms because I can use them interchangeably on a test. So you might want to star that to come back to it later. Find the solutions for the quadratic given the factors. So in order to do this question, we would need to set each term equal to 0. So x plus 4 is equal to 0. X minus 5 is equal to 0. On the left side, we just subtract 4, so we get x is equal to negative 4. And on the right side, we would add 5, so then x is equal to 5. Okay, you can write it like this. Okay, this would be an and statement because x is equal to negative 4 and x is equal to 5. Or you could write it in one singular x equals, so x equals negative 4 and 5 like that. So either one of these works and is a good answer for these types of questions. Number 2, same thing, right? 2x minus 3 equal to 0, x plus 1 equal to 0. So then you get add 3, 2x is equal to 3. And on the other side, you get x is equal to negative 1. So then x is equal to 3 halves and negative 1. All right, so the next one says find the zeros / roots of the quadratic equation by factoring. So the first thing we need to do is factor. So in this case, just put the factors right here. It's an a value of 1, so it's just both x in the first front two. Plus on the end, it tells us that they're matching. Plus in the middle tells us that they're both plus. In this case, it would be 2 and 2. So if we solve this, x plus 2 equals 0, x plus 2 equal to 0, you can see that we actually only get 1 0 for this answer. It's just x would equal negative 2. Okay, we wouldn't want to repeat the negative 2. We would just want to say it one time, x equals negative 2. For this next one, we have factors. A is 1, so it's x and x. Negative, so it's plus and minus. It looks like positive 8, negative 4. So then our zeros would be x equals negative 8 and positive 4. Okay, so hopefully it starts going faster as you see the factors. This next one, we need to factor it. So greatest common factor this time, we have x comes out of both of them, so we get x plus 6. Set both of these equal to 0. This is one of our factors. This is the other factor. So x is equal to 0, and then x plus 6 is equal to 0. So then our two answers here would be 0 and negative 6. Okay, this is huge. A lot of people forget this, so be careful. When it's just an x by itself on the outside, that means it's 0. All right, last one of these examples. Now we have an a value that is not going to be 1. I'm going to split it into 3x and 2x. Let's see where we can get there. Negative here tells us that it's plus and minus. So I'm kind of leaning towards maybe 5 and 2 for my factors. So what if we went negative 5 here, positive 2 here, right? That would give us 4x. This would give us negative 15x, which does make negative 11, so we're good. So then our answers would be x is equal to negative 2/3 and x is equal to 5 halves, right? How did you get that? 3x plus 2 is equal to 0, so that would be 3x is equal to negative 2. X is equal to negative 2/3. And then 2x minus 5 is equal to 0, so 2x is equal to 5, which means x is equal to 5 halves. okay? And so those would be our two answers. Again, the factoring when a is not 1 definitely can be trickier. So I understand that. So for this next section, it says, find the x-intercepts of the quadratic by factoring, then graph the function in your calculator and verify the x-intercepts. Okay, so let's take a look at this next one. Factors here. We have x and x, negative 40, looking like 8 and 5, so negative 8, positive 5. So then our x-intercepts, if we solve these, we would get x is equal to negative 5, x is equal to 8. When we write intercepts, we always use their ordered pair, so negative 5, comma 0, and then 8, comma 0. So what does this graph look like? Without a graphing calculator, you can actually graph these, just really rough sketches. We need to go negative 5, so 1, 2, 3, 4, 5. So negative 5, we should have a circle. Positive 8, 1, 2, 3, 4, 5, 6, 7, 8, also a circle. And then positive squared tells us it's opening up, so then it's going to look something like this. Whoop. Okay. This next one, same idea, right? This time the factors are going to be 3x and x. Negative at the end tells us that they're not the same. I'm leaning towards 4 and 2 here because 4 is going to give me 12. 12 is close to 10. So I'm going to go positive 4, negative 2. So that's negative 2x, positive 12x. Yep, gives us positive 10. So then our x-intercepts here, we're going to have x, 3x minus 2 equals 0. So that's going to be 2 thirds. So 2 thirds and 0. On the other side, we would have negative 4 and 0. And then we can graph this. 1, 2, 3, 4. Positive 1. So 2 thirds would be right there. Negative 4 would be right there. Again, it opens up because it's positive. So it looks something like this. All right. So here's another type of question we can see, knowing now that factors are roots or x-intercepts or solutions to the equation. It says if x is equal to negative 7 and x is equal to 3 are zeros, write a possible function in standard form with those zeros. So if we ever get this, what we need to do is we need to set the equation equal to 0. So we're going to add 7 to both sides. That would give us x plus 7 is one of the factors. Subtract 3 to both sides, we get x minus 3 is another factor. So then we can multiply these two things together, and we would get x squared plus 7x minus 3x minus 21, which gives us the final answer in standard form, x squared plus 4x minus 21. Right, that positive 4x comes from positive 7 minus 3, and then that would be our final answer. Okay. Last but not least, we could also see word problems that deal with factoring questions. Okay, so when we deal with word problems, definitely a little bit harder, as always, but just think through this question as it's read to you. Draw pictures when you can. In this case, I'll always ask for the picture. Okay, a picture will be part of the points for this question on a test. So you need to know how to draw its picture. We have a rectangular picture that is 2 feet by 4 feet. So then we can draw that, right? It's 2 feet by 4 feet. So it'll look something like this. This is our picture. It says you have 7 square feet of wood to create a frame that has a uniform width for your picture. So 7 square feet of wood. That tells us that a length times a width is going to be equal to 7. Okay? It says, what should the width of the frame be? Hint, draw a picture. So it says that we're going to draw a uniform width around this picture. So uniform width x deep like that, and then it's going to go x to the side like this. So at every single corner, we should have 2 x's coming off of it because we want uniform width all the way around, right? So then we have this drawing that looks like this. Boom. Okay. This is our drawing. Perfect. It asks for the dimensions of the bigger rectangle, consider the x's. So it wants to know what is this distance right here, right? Well, we have an x here, we have an x here, and then the distance in the middle is 4. So then that bottom distance is going to be 2x plus 4. On the side, right, we have something very similar. We have x here, 2 in the middle, so that's 2x plus 2. So the dimensions, right, or the length and the width of this thing is going to be 2x plus 4, and then the length is going to be 2x plus 2. So those would be our new dimensions. Starting from the dimensions of the bigger rectangle, we need to multiply this through. Okay, so when we multiply this through, it's going to be 4x squared plus 4x plus 8x plus 8, which would give us the dimensions of the bigger rectangle to be equal to 4x squared plus 12x plus 8. Okay, so those would be the dimensions of the bigger rectangle that we have all the way around the outside. It's asking us for the area of the bigger rectangle. So this one's a number here, right? The area of this inside, the picture, is going to be 2 times 4, which would give us 8. The area of the outside, right, or the border, is going to be right here. It's given to us in the question. You have 7 square feet. So the picture frame is 7. So then we add these two things together. The total area that we're taking up is 8 plus 7, which is 15. So now we're going to set those two things equal. 15 is equal to 4x squared plus 12x plus 8. We subtract the 15 from both sides. We have to do that so that we can factor this problem. So 4x squared plus 12x minus 7. Okay. Since it's set equal to 0, now we can factor. So we get, I'm going to say 2x and 2x. We have 1 and 7 are our only factors in the back, so we need positive 12. Something in positive 7 would give us positive 14, negative 1. So then we have 0 is equal to that. So now we just set both of these equal to solve for x. So we set 2x minus 1 equal to 0, 2x plus 7 equal to 0. So now we have x equals 1/2 and x equals negative 7/2, right? Because this is a real-life problem, distance cannot be negative, so we are not going to include this in our answer. So the only answer to this question is x equals 1/2 of a foot. Okay, so if you like that method, that's awesome, okay? But there's another method on the key that's a little bit different than this one. So if you want to check that method out, feel free to do that. I actually like the method on the answer key on Canvas maybe a little bit more than the one that I just did because it makes more sense to me, but it's always what makes the most sense to you, okay? So check that one out also if you weren't sure about how this method worked to solve for x. All right, last question here. Jeff has a rectangular swimming pool that is 20 feet long and 15 feet wide. He builds a deck with a uniform width x around the outside of the pool. So this time we have a pool, we go 15 here, we're going 20 here. He wants a uniform deck around the outside of length x, right? So this should look exactly like our last question. Okay, and it should work very similar to our last question, right? The dimensions of the bigger rectangle, oh wait, sorry, I didn't finish reading the question. After the deck is built, a total of 414 square feet is occupied by the deck and the pool. Okay, how wide was the deck that was built? So the dimensions of our bigger rectangle, we have 20 plus 2x times 15 plus 2x. Okay, so what's that going to give us? That's going to give us 4x squared plus 30x plus 40x plus 300, which would be 4x squared plus 70x plus 300. So here's the dimensions of our bigger rectangle when we multiply them together. The area of our bigger rectangle is in the question, right? This is the area of the bigger rectangle, so 414. So then to set this problem up, we would go 414 is equal to 4x squared plus 70x plus 300. We subtract off 414 from both sides. We get 0 is equal to 4x squared plus 70x minus 114. Okay, now we need to do some solving from here. Well, these are all even numbers, so at least 2 will come out of all of them. That should make factoring easier. 2x squared plus 35x minus 57. Okay, and now comes the hard part, right? Thinking of the factors of 57. I think 1 and 57, and then I know, because I know the answer, that 3 and 19 are also factors of 57. So then as we're coming through here, we can actually do this first. Divide everything by 2. That would cancel this 2 and this 2. And we can do that because then it will equal 0. So then we can go 2x squared plus 35x minus 57. Now we can write the two factors, right? We're going to have 2x in one, x in the other. Okay. And then we need positive 35 in the middle. Okay, well, 2 times 19 is going to give us 38. So I like positive 19 here for 38. Negative 3 here brings us down to 35. So then our answers are x equals 3/2 and x equals negative 19. Again, real life problem. Distance can't be negative. So then our answer is x is equal to 3/2 of a foot. Okay, so his wooden deck around his pool is going to be 3/2 of a foot past the pool deck length. All right, so these word problems are tough. Okay, I made a couple mistakes filming this, so it's okay if you're making mistakes or not completely understanding how to do them. Try the homework the best you can and then come with questions. All right?